Dear students, now the topic ionic equilibrium. In this topic, we see the session 2, strength of acids and bases. Before that, last session, we already saw the theories, various theories of acid and bases. Now, in this session, strength of acids and bases. Strength of normally we know that strength of acid and bases are which is strong acid, which is strong base, which is weak acid and which is weak base. In terms of this, we know that. But in chemistry, the strength of acid and bases are defined by the concept of concentration of H plus ion and OH minus ion. This is in terms of ionization constant or dissociation constant. That is the concept of this strength and strength of acids and bases. Now we move the topic. The strength of acid and bases can be determined by the concentration of H3O plus or OH minus produced per mole of the substance dissolved in water. The chemicals, any chemicals dissolved in water, they dissociated to H3O plus or OH minus per mole. They give the concentration, concentrated solution. Okay. Generally, we classify the acids, bases either as strong or weak. And already explained. The strong acid is one of the almost completely dissociated in water. The strong, this is the definition for strong acid. Strong acid is completely dissociated in water, while weak acid partially dissociated in water. Weak acid means partially. Partially means small molecules. Small molecules are dissociated in water. Next, quantitatively define the strength of an acid. Acid, for example, generally HA, H plus ion, A minus ion. By considering the following equilibrium. The equation is HA plus H2O gives, equilibrium gives H3O plus A minus. HA is acid, H2O is base, H3O plus is acid, A minus is base. The equilibrium constant of the above ionization is the following expression. For this equation, HA plus H2O equilibrium, H3O plus A minus. For this, the equilibrium constant is K is equal to the concentration of products divided by concentration of the reactants. That is H3O plus A minus concentration of HA into concentration of H2O. This is the equilibrium constant K. Next, we can omit the concentration of H2O in the above expression because H2O is generally the constant is 1. Constant value is 1 for water. So, you omit the concentration of H2O. The expression, since it is present large excess and essentially unchanged. This is the reason for 1. H2O is equal to 1. The large excess and essentially unchanged. This is the next step. Ka is equal to, Ka means acid, constant, the ionization constant of acid is equal to concentration of H3O plus into A minus divided by concentration of HA. Next, Ka is the ionization constant or dissociation constant of acid. Okay, underline it. What is Ka? It measures the strength of the acid. Acids such as hydrochloric acid, nitric acid are almost completely ionized, and hence they have high Ka value. In laboratory, the acids normally inorganic acids, hydrochloric acid, nitric acid, and then sulfuric acid, they are dissolved in water. They completely dissolved in water, that is completely ionized in water. Okay, so higher Ka value, they have the higher Ka value. Next, formic acid and acetic acid, they partially dissociated in water, because they are a weak acid. They are the weak acid, organic acid. Understand? They are the organic acid, formic acid and acetic acid. The value is already given at 25 degrees centigrade, 2 into 10 to the power of 6 for inorganic acid, 2 into 10 to the power of 6. Formic acid 1.8 into 10 to the power of minus 4 at 25 degrees centigrade. Acetic acid 1.8 into 10 to the power of minus 5. That is formic acid minus 4 and then acetic acid minus 5. They are partially ionized in solution. In such cases, in these cases, they are equilibrium. It occurs the equilibrium. We maintain the equilibrium between unionized molecules and dissociated ions. They maintain. So the Ka value is less than inorganic acid, lesser than inorganic acid. Generally, acids with Ka value greater than 10, Ka value greater than 10 considered the strong acid. Less than that, they are the weak acid. This is the concept. Okay, understand? What is Ka? This is the definition. Next, let us consider the dissociation of HCl in aqueous solution. Now, the equation HCl plus HOH equilibrium H3O plus Cl minus. HCl is acid 1, H2O base 2, H3O plus acid 2, and then Cl minus base 1. In this equation, HCl dissociated H plus and Cl minus. The H plus is combined with H2O gives H3O plus, that is acid 2, and then Cl minus is separately ionized. Okay, separately ionized. Okay, in this equation, acid 1 and base 1, HCl and Cl minus, they are the conjugate acid base, and then water molecule and H3O plus, it is a conjugate acid base. Okay, now earlierly last session, due to the complete dissociation, the equilibrium lies almost 100% to the right. That is right side. Right side means the Cl minus ion has only the negligible tendency to accept proton form H3O plus. The Cl minus, it is a negligible tendency to accept proton. Okay, it means conjugate base of strong acid. This is very, very important point. Conjugate base of strong acid. Conjugate base of strong acid. Strong acid means HCl. In this HCl, conjugate base, which is the conjugate base? Cl minus is the conjugate base. It is a weak acid, and vice versa. Weak base, conjugate acid of base, H2O is a strong acid. Vice versa is a another one concept. Okay, first concept, conjugate base of the strong acid. Conjugate base of the strong acid means HCl release Cl minus. The Cl minus is the conjugate base of strong acid. It is a weak base. Then H2O release H2O take the H plus ion combined to form H3O plus ion. So H2O is a weak base, but gives the strong acid H3O plus. This is the concept. So next, you give the chart relative acid strength. Topper, strong acid, from strong acid to weaker acid. Strong acid to weaker acid. We give the topic in diagram. This is the strong acid, this is the weaker acid. From left to right, H3O plus, HClO2, HF, H2CO3, CH3COH, NH4 plus, HPO42 minus, and then H2O. These are the range, left to right, increasing acid strength. Next, relative conjugate base, weaker base. In this side weaker base, that side is stronger bases. Weaker bases from water molecule. ClO2 minus, F minus, HCO3 minus, and then CH3COO minus, NH3, PO4 3 minus, and then OH minus. The range from left to right. Okay, understand? The following table, the above table indicates that the relative strength of conjugate acid base pairs. Okay. In this table, from bottom to top, increasing order of strong acid, from weak acid to strong acid, Okay. This is the range of conjugate acid base pairs, relative strength of acid base pair. Okay. This is the acid, very weak acid, hydrogen, OH minus, ammonia. This is increasing order. In this bases, top to bottom, increasing order, weak bases and then strong bases. This is the order. Okay, understand? Next, ionization of water. Next topic, ionization of water. What is ionization of water? When an acidic or basic substance is dissolved in water, if any acid or basic substances is dissolved in water, depending upon its nature, it can either donate or accept proton. In last session, we already saw the Lowry-Bronsted theory. Donate proton, accept proton. Okay. In this concept here, ionization of water, some chemicals dissolved in water, any compound dissolved in water, depending upon its nature, they are donate or accept a proton. Okay, this is the concept. In addition to the pure water itself, the little tendency to dissociate, that is, one water molecule donates a proton to another water molecule. Pure water also itself, pure water means H2O also a tendency to dissociate. From this equation, H2O, we write the H2O molecules, two type OH minus H plus, and then it has the one lone pair of electron. It has a lone pair of one molecule lone pair of proton given to the H plus ion, proton donation to H plus ion. Okay, therefore one molecule changes to H3O plus and one molecule OH minus ion. In this equation, the OH minus and water molecules are the conjugate as base pair, and another molecule H2O is a base, act as a base, and H3O plus as it is a conjugate pair. Okay, understand? This is called the auto ionization of water. Auto ionization of water. In generally water molecules, there are two molecules. One molecule HOH, that is OH minus H plus, and then one molecule the lone pair of electron. Donate the lone pair of electron. Okay, this is the concept from this equation. In the above ionization, one water molecule acts as an acid while another molecule acts as a base. This is the final conclusion from this concept, ionization of water. Understand? Now the dissociation constant for the above ionization is given by as per concept of constant, ionization constant, K is equal to product, concentration of the products, H3O plus, from this equation H3O plus and OH minus divided by H2O square. Square means two molecules of H2O. That is reactants. Water itself, auto oxidation. This is the rate constant for this auto oxidation. Okay. Next, the concentration of pure liquid water is 1. Already know that H2O value is 1. Therefore, in this base, that is reactant value is 1. So concentration Kw, W means water, Kw is equal to H3O plus OH minus. So Kw represents the ionic product constant, ionic product. This is a concept. Okay, what is Kw means? The ionic product of water, Understand? Now next, it was experimentally found that from this equation, experimentally found that the concentration of H3O plus is in pure water is 10 to the power of minus 7. 1 into 10 to the power of at 25 degrees centigrade. We already discussed earlier. Concentration of H3O plus in pure water. The dissociation of water produces equal number of H3O plus and OH minus ion. In this equation, H3O plus and OH minus ion. So the concentration of OH minus ion is also the same value. This is the concept, very important concept in this equation. Okay. Next, from this concept, we see the ionic product of water. What is ionic product of water? Kw is equal to H3O plus and OH minus ion. 1 into 10 to the power of minus 7 into 1 into the power 1 into 10 to the power of minus 7, that is 1 into 10 to the power of minus 14. Kw for ionization product value is equal to 1 into 10 to the power of minus 14 for water. This is very important question for 2 mark. Okay. Next, Kw is a constant at a particular equilibrium. For all equilibrium constant, Kw is also a constant at a particular temperature. The dissociation of water is an endothermic reaction. Endothermic means it releases the temperature due to the with the increase in temperature, the concentration of H3O plus and O is also increases. In our regular life, increasing in temperature in water, the concentration of ions are also increased. The ionic product also, in this concept, the ionic product also increases. Very important point. From this tablet column, temperature 0 degree centigrade, 10 degree centigrade, 25 degree centigrade, 40 degree and 50 degree. Kw value is gradually increased in this tablet column, because already you see that the increase in temperature, the concentration of H3O plus and OH minus ion also increases, because they due to the temperature, they completely ionized, easily ionized. So the ionic product was increases. Okay. In neutral aqueous solution, that is like a sodium chloride solution, neutral aqueous solution, that is salt. In kitchen, we take the salt and dissolved in water, the aqueous solution. The concentration of H3O plus is always equal to the concentration of OH minus, whereas case of aqueous solution of the substance may have an acid or base. The concentration of H3O plus will not be equal to OH minus. This is the concept for acid and bases. First concept is neutral solution, neutral salt solution. In salt solution, the H3O plus ion and OH minus ion is equal quantity. But in water, but in acid or bases, the concentration is not equal. Understand? Now, in aqueous solution of HCl, the addition of auto ionization of water following equilibrium due to the dissociation of HCl can also exist. HCl plus H2O equilibrium, H3O plus and Cl minus. HCl is dissociated with H plus and Cl minus. This H plus combined with the water molecule gives H3O plus and Cl minus. This is the auto ionization of water. In case of addition to the auto ionization of water, HCl molecules also produces H3O plus ion by donating proton to water. This is another important concept. HCl produces H3O plus ion by donating a proton. You already know that H plus and Cl minus. It split into H plus ion and Cl minus ion. The H plus ion is combined with H2O. This is the meaning for this. So H3O plus greater than OH minus ion. This is the very important point. In acid, hydrochloric acid, H3O plus always greater than OH minus ion. It means aqueous HCl solution is acidic. You already see, we know HCl is a strong acid. In basic solution, ammonia OH minus is concentration is greater than H2O plus ion. Okay.